So now we're going to look at how to find the inverse of a function. So in a sense, when we covered the theory, you already know what to do. Remember that finding the inverse of a function accounted to switching inputs and outputs, which is to say switching x and y. So here's how we start. We write the function as y equals f of x. As such, y equals 3x minus 2. Then we interchange x and y. So this becomes x equals 3y minus 2. Now in this new equation, we solve for y in terms of x. So x plus 2 is 3y and x plus 2 over 3 is y. So the f inverse x in this case is x plus 2 over 3. Now, one important step for once you have found the inverse is the process of verification. When you verify, there are two things you need to verify. You need to verify that f inverse of f of x is x, and you need to verify that f of f inverse of x is x. So for example, in this case, f inverse of 3x minus 2 would be 3x minus 2 plus 2 over 3, which is x, and that works out. And f of f inverse x is f of x plus 2 over 3, which becomes 3 times x plus 2 over 3 minus 2, which is x. Which means this makes sense. So it is a verified expression for f inverse x. Let's look at another example. Find the inverse of x to the 5 minus y minus 3 over 2. So we start by writing this as y equals x to the 5 minus 3 over 2. Then we do the interchange step. Once we do the interchange step, we solve for y. Now solving for y just means applying inverse operations. So you multiply by 2, then you add 3, and finally you get that it is 2x plus 3 to the power 1 over 5, which is now your f inverse of x. Once you're done with all of this, you still need to verify. So f of 2x plus 3 to the power 1 over 5, that's going to be 2x plus 3 to the power 1 over 5 to the power 5 minus 3 over 2. But these powers multiply, and 1 over 5 times 5 gives me 1. So this is 2x plus 3 minus 3 over 2, which is back to being x. Similarly, f inverse of x to the 5 minus 3 over 2 would be 2 times x to the 5 minus 3 over 2 plus 3 to the power 1 over 5, which comes out to x to the 5 minus 3 plus 3 to the power 1 over 5, or x to the 5 to the 1 over 5, which gives me back x. And once I have x, then it is verified that that is indeed the correct inverse form of the function. Let's look at one more example. In this case, we look at a rational function. So we start off by saying y equals 2x plus 3 over x minus 1, and then we do the interchange step. So x is 2y plus 3 over y minus 1. Now here it looks like it's slightly complicated. So the first step is to cross multiply. when we cross multiply, xy minus x is 2y plus 3. So let's isolate the y terms. Xy minus 2y is x plus 3. Y times x minus 2 is x plus 3. So y is x plus 3 over x minus 2. And that is F inverse x. We still need to verify. So F inverse of f of x, which is 2x plus 3 over x minus 1. So I'm going to do one of the verifications and then you should try the second one on your own. This one is slight bit involved, and that is F inverse. So this is what has to go in place of x. So I have 2x plus 3 over x minus 1 plus 3 over 2x plus 3 over x minus 1 minus 2, which then becomes 2x plus 3 times x minus 1 over x minus 1 divided by 2x plus 3 minus 2x plus 2 over x minus 1. Okay, maybe looks like I need more space for this. Okay, we'll deal with that later. Okay, so that is then 2x plus 3 plus 3x minus 3 over x minus 1, 2x plus 3 minus 2x plus 2 over x minus 1, which is then 5x over x minus 1 times x minus 1 over 5. They cancel out. They give me back x as expected. Okay, we should take out some time and finish the second part. Is that, yeah. So this one too will be a little involved calculation, but it should eventually come out to be x. Okay, now let's look at the graphical interpretation of x. Actually, maybe put it down here. Now we can come back to this. Okay. Now let's say this is the graph of a function y equals f of x, right? So this means, let's say I have an input a, b, c. Now at a, that's my output, fa. At b, that's my output, fb. And at c, that's my output, fc. Now what I do know is that finding the inverse means they sort of switch. So now the ABCs are going to be here, right? And the f of a and the f of b and the f of c's are going to be in here. So that is now going to be f of a, that is now going to be f of b, and that is now going to be f of c. So if you connect them, they're going to look something like that. But that doesn't establish a pattern. The pattern is going to be established when we look at what happens to the ordered pairs. What happens to the ordered pairs? And here's what happens. So in the function f, if you have a ordered pair AB and you go into the inverse, it becomes b comma a, because the x and the y interchange, right? So this can be physically achieved by a reflection of the graph of f of x about the line y equals x. And here's why that works. If you reflect anything on this line, your inputs and the outputs get exchanged. Point AB becomes a point BA. And that's because this is the line where y equals x, and when you travel across it, the y and the x interchange. So another quick way to obtain the inverse graph would be to just reflect that. Let's apply that to an example. Sketch the graph of square root of x minus 2. So that is a radical function, which means x has to be more than 2, and at 2 it is 0. So that is f of x. Now from this, if I have to graph, okay, let me make it slightly differently. Right. That's the y equals x. That's 2 right here. That's what that graph looks like. That's f of x. Now to get the inverse function, what I have to do is I have to systematically take a reflection of this so that it looks something like that. Okay. Now remember, it cannot be less than 2, which means that your output now cannot be less than 2. And to verify that, let's do it algebraically. So if y is root of x minus 2, then x is root of y minus 2, and x squared is y minus 2, and y is x squared plus 2. And what does that look like? That looks like this parabola, where this point is 0, 2. So that makes sense. What you see here is exactly this branch of the parabola. Let's look at another example, an inverse function. At a local pizza parlor, the daily special is $12 for a plain pizza plus $2 for each additional topping. Find a function that models the price of the pizza with n toppings. Okay, so first, so the price is going to be $12 plus $2 plus $2 plus $2 plus dot dot dot, depending on as many number of toppings. Right. Now suppose it says we have n toppings. If we have n toppings, then the price is 12 plus 2n. So that becomes my price function, but instead of x, we're going to use n because it depends on this variable n. And part B says find the inverse of this function. Right, so inverse of this function, in order to maybe work in a more familiar environment, let me call this f of x for the purposes of finding inverse. Then we interchange, so x is 12 plus 2y, x minus 12 is 2y, and x minus 12 over 2 is y. So that is f inverse of x. And then it says, what does it represent? So f inverse, what does it represent here? If this represents the cost, then this represents the number of toppings that you chose. And that's going to answer part C. It says, if a pizza costs $22, how many toppings does it have? So 22 equals x minus 12 over 2. Sorry. So we are trying to find f inverse of 22. So that's going to be 22 minus 12 over 2, which is 10 over 2, which means there were 5 toppings on this pizza. So it's a five-topping pizza. So one of the utilities of inverse function is to be able to find what input is required to get a particular output. That's it. That brings us to the end of inverse functions and how to evaluate inverse functions. Thank you.